All right, good afternoon. Continuing with where we have left off in the case of inequalities, and we have on page 109. Okay, so we're looking at solving for x, and we're looking at three modes of solving, one of which will be graphing, and another of which will be in the case of the set builder notation, and then we have something you'll be seeing time and again, which we will have with interval notation. Now we have in this inequality, we have that negative 2x minus 5 is greater than 17. And if we look at solving for x, okay, just as we would in equations, we're going to isolate the variable term. Okay, so adding 5, okay, to both ends. Okay, so we have on the left, we have negative 2x. And to the right, okay, you have 22, so we have negative 2x is greater than 22. And looking at isolating x on the left, okay, so if I divide by negative 2, what's going to happen here in the case of inequalities? Okay, if I multiply or divide by a negative, okay, the direction of the inequality is going to change. Okay, so just to mention, okay. Again, inequality direction changes when multiplying or dividing by a negative. But not in the case of adding or subtracting. All right, so for what we have in the dynamic that is created, okay, so left-hand side, okay, we're going to have that x is less than negative 11. Okay, so this is going to be our defining inequality. And if I express what I have as a graph, and just a little bit of a sketch here, and okay, so if I have, like, say on a number line, if I have the number negative 11, so negative 11 is not included, so I could have like a parenthesis or an open circle, and then for the values less than negative 11, I'm going to have a ray that's going to go continuously out to the left, whereupon the lower limit, okay, will be extending out to negative infinity. Okay. And for what is referred to as the set builder notation, okay, this is just essentially going to repeat the inequality solution. And for what is referred to as the set builder notation, okay, we're going to have grouping symbols in the form of braces. Okay, and the opening statement will be the set of all values in the variable, in this case the set of all values of x, such that, and then we have that x is less than negative 11. And for what we have in the case of the interval solution, again, this is our parentheses and brackets notations. And okay, so we have in this case for the interval solution, again, the lower limit, okay, we have approaching negative infinity. And again, we have the upper limit, okay, you have approaching but not including negative 11. Okay, so we're going to have the use of parentheses throughout. Now, in the case of what we have for number 10, okay, this time we're looking at going from solving for x to solving for t. And we have for this inequality, we have negative 8 times t, followed by the addition of 1 is less than 17. Okay, so we have 17 again as our constant presented on the right. And just as I had isolated negative 2x, I'm going to do the same thing with negative 8 times t. So I'm going to move the constant alongside it, okay, by subtracting. So we have in this framework, so I now have that negative 8t is less than 16. Okay, and once again, I'm going to have the inequality direction to change as I convert negative 8t to t only. And this time we're looking at changing the direction from less than to greater than. Okay. And just kind of re-emphasize again, so we have changes in the inequality direction for both items because we had division by negatives. And so we have on the left, okay, we now have the inequality solution in t to be t is greater than negative 2. And for what we have in the case of the graph, okay, so we have negative 2 not part of the solution. So we have an open circle on this, and the values, okay, will be greater than negative 2. So this time we're going to have the direction of the graph to proceed to the right. And for the set builder form, okay, so we still have the use of braces. And this time we have the set of all values t such that t is greater than negative 2. For the interval outcome, again, this is sort of going to replicate what we have in the graph. So we have the limits you have involving negative 2 and infinity. Now, again, negative 2 because there's a lack of an equal sign. Okay, we had, again, a hole at negative 2, and in the interval we will have a parenthesis. And again, infinity and negative infinity are boundless. Okay, so we still maintain the use of parentheses. So this will be the interval display for what we have in number 10. Okay, now for what we have for number 16, okay, this time we're looking at solving for the variable m, and we have the expression in the variable is now going to be on the right hand side of the inequality. So we have that negative 14 is less than 3 times the quantity of m minus 7, followed by the addition of 7. And okay, and tell you what, we can go ahead and distribute, just take care of the parentheses, and we have upon doing so, we're going to have 3m minus 21 followed by the addition of 7. So now we got negative 14 is less than 3m. Negative 21 plus 7 is going to be negative 14. And upon isolating 3m, so we're going to move the constant 14 over by adding. And once we do so, we're going to have cancellation of terms. So we got 0 is less than 3m, and getting that m by itself. So if I divide by 3, okay, this time we are dividing by a positive constant. Okay, so the inequality direction will remain fixed. Okay, so 0 divided by 3 is 0, and we have that 0 is less than m. And looking at this result, if I rewrite this in its logical equivalence, okay, whereupon I'm going to have m on the left hand side. Okay, so we're going to have, in effect, okay, to say that 0 is less than m, this will be the same logically as m is greater than 0. And so just looking at what we have in terms of graphing. Okay. Notice earlier, okay, we had the compared to number in the result, -11 in the first problem, -2 in the next. Okay, and again, the final inequality had no equal sign, so those values were excluded. And guess what? The same thing is going to happen with 0. So on 0, okay, we're going to have a hole in the graph, and then greater than 0, so we're going to have once again you have a ray that's going to go out to the right. So again, we're going past 0 and approaching infinity. So we have for the set builder form, okay, this time we're looking at the set of all values m such that, and then closing out with the defining inequality, we'll have that m is greater than 0. And just once again, for what we have in interval notation, okay, so we have parentheses exclusively around 0 and infinity. All right, and we'll be looking at these reapplications, okay, once we get back into the absolute value inequalities. Now, in terms of linking words, and I'm going to stress those, especially once we get into the absolute value inequalities and convert to just your regular inequalities. And now for 27 as well as 28, now there is a stress on the linking words and or. Now when you're looking at the term and between inequalities, okay, you're looking at fixating upon what is common between the inequalities. Whereas the word or, you're looking at combining everything, shared or not, between inequalities. So the words, in other words, and is fixated upon what is shared or common between inequalities, whereas or combines everything, shared or not. And for what we have in the case number 27, just to give you a bit of a visual layout, we have for the two inequalities of concern, okay, we have x is less than 4. For the first that is mentioned, then we have the second, we have with x is greater than or equal to -2. And if I were to put, let's say, as a number line display, okay, so we have with x is less than 4, so for x is less than 4, okay, so 4 is not included. It's just that everything in x is less than 4. So I'm going to have an open circle or parenthesis on 4. Then for less than 4, so I'm going to have activity going continuously out to the left. Now for what we have for x is greater than or equal to negative 2. So we have negative 2. And thanks to the equal sign, negative 2 is going to be part of the set. So I'm going to have a closed point at negative 2. And the rest I have greater than, so I'm going to have a ray to go continuously to the right. Now, in looking at what's going to be involved, okay, whenever we take x is less than 4, and x is greater than or equal to negative 2, again, so you're going to be looking at what will be shared in common. Okay, so just looking at kind of like an intersection. Okay, so you have so for what will be shared between the sets. Okay, so you have, again, so you have negative 2 and 4. And we're going to be inclusive of 2. So you're looking at what is shared, what intersects the graph. So you have everything going from negative 2, approaching, but not quite including 4. And guess what? We're going to have the formation of a line segment. Okay, and so the way of looking at this, okay, so we got just kind of putting it as a compound inequality. So you have negative 2 is going to be less than or equal to x, which in turn is going to be less than 4. Okay, so just kind of taking this combination. So x is greater than or equal to negative 2. That's like the same as negative 2 is less than or equal to x. And guess what? X in turn is less than 4. So combining these two statements would translate to the compound inequality that we have here. And just for what we have in the case of the interval, that results from taking x is less than 4 and x is greater than or equal to negative 2. And we have the lower limit. Okay, we have including negative 2. And we have approaching but not quite including the value of 4. Okay, so you're essentially going from negative 2 to like 3.9999, but never quite getting to 4. Now, where we have the linking word or, you have x is less than 4 or x is greater than or equal to negative 2. And that's just going to combine everything that exists between the inequalities. So everything less than 4, everything greater than or equal to negative 2 is going to be in the mix. Okay, so there's going to be a bit of cascading throughout. Okay, so again, we had negative 2 and 4. So again, when we had started out with values of x less than 4, we were going this way, and then joining with those values of x greater than or equal to negative 2. Guess what? So we started here and went to the right, and guess what? That's going to run through 4, and 4 is going to wind up being included in the mix. And guess what? We have going endlessly from end to end. No, I should say not end to end, but between negative and positive infinity. So with what we have in result, okay, we wind up essentially with a set of all real numbers. And again, the set of all real numbers has for the interval notation, okay, parentheses surrounding negative and positive infinity. And for what we have, just sort of tying in together, okay, what we have with the words or and this time we have, say for 28, we have working with the variable y. Okay, so here we have y is less than or equal to -2. And we have that y is greater than -5. Now we'll just plant -2 right here. So for less than or equal to -2, so yeah, equal to -2 is part of the inequality, so you have a solid point. Everything else being less than. So we have a ray that's going to be going out to the left. And for y is greater than -5, so -5, and since we don't have an equal sign, again, we're going to label the exclusion of -5 with an open circle, and again we have greater than, so you have a ray that's going to go continuously to the right. And just looking at combining, say, the statement y is less than or equal to -2 and y is greater than -5. Again, just for the limits of concern. Okay, so you have again, so you have -5 and -2. And again, and is limited to what will be shared in common between the graphs. So you have in common those values, okay, that will be greater than -5, and also between that and including -2. And so we're going to have a line segment. And notice we have in the dynamic, okay, that is carried out. So you have a line segment, and this would be, you have -5 is less than x, which in turn is going to be less than or equal to -2. So just like consolidating these two statements, okay, with the word and. Okay, so again, we have not x but y. So y is greater than -5 is the same logically as -5 is less than y. Y is less than or equal to -2, so just relaying this over, and voila. Okay, so you have -5 is less than y, which in turn is less than or equal to -2. And just for the interval notation, with this intersection, okay, so you have -5 is not included, so this will stay in the parenthesis. And we have approaching and including -2, and the inclusion is signaled by the bracket. And for y is less than or equal to -2, or y is greater than -5. Again, so we are combining everything that is involved. Okay, so you have for y is less than or equal to -2. It's kind of like taking these pieces and putting together. I guess you can say it's about like taking, sections of a Kit Kat bar that were separated and then trying to put them back together. And we have with y is greater than -5, well, guess what? Okay, you had the line going through, so -5 is going to be included in the intersection. And guess what? So we have for the end result here, we have everything going continuously from end to end. So you have the set of all real numbers, and that bit of history repeats. For again with the or statements and applying to these inequalities, we come out to the set of all real numbers. And again, the interval will have parentheses around negative and positive infinity. All right, and then we have crossing over into, once again, the threshold, okay, concerning absolute value inequalities. And again, just sort of restating what we had the other day. Okay, so we have with absolute value. Okay, so we have that k is a non-negative value. Again, we have, first of all, okay, so we have that the absolute value of x is equal to k. Again, we have x equal to plus or minus k. Just like two numbers with an absolute value of 17 would be 17 and -17. And again, just with what we have in the inequality, if I have that the absolute value of x is less than k, then you have your compound inequality have -k is less than x, which in turn is less than k. And just now, again, this compound inequality statement, this would be like taking the uniting of where we have that x is greater than -k and x is less than k. Once again, the interval solution will be parentheses around negative and positive k. If I have that the absolute value of x is less than or equal to k, once again, as I take out the absolute value bars, we're now going to have the compound inequality statement whereupon we have -k is going to be less than or equal to x, which in turn will be less than or equal to k. And again, this is kind of like translating where we have x is greater than or equal to -k and x is less than or equal to k. And just the interval notation, you have brackets around negative and positive k. Right. And then where we have a change in the direction, okay, if we have that the absolute value of x is greater than k, okay, so you're looking at increasing the distance away from 0 on the number line, both in the negative direction as well as the positive direction. So this is where your or statements will come in. So we can say we have that x is going to be either less than negative k, or that x is going to be greater than positive k. And just for the interval notation, so x is less than negative k, so we have from negative infinity to negative k in parentheses. So this references x is less than negative k. Now, or, this is where the union symbol comes in, just signaling that we have a bit of a detachment between the interval sections. And then we have x is greater than k, so you have a parenthesis around k, and you have the other portion for this second half, you have where the upper limit approaches infinity. And where we have the absolute value of x is greater than or equal to k. Okay. Now you're going to have the x is less than or equal to negative k. Or that x is greater than or equal to k. And you're almost going to have the same interval statements, but this statement is going to be inclusive of negative and positive k. So you're going to have negative k is going to be bracketed, and so will k. Okay, and so just taking what we have in the properties, we have from the exercise set where we have absolute value inequalities involved for number 48. Okay, now we got 2 times the absolute value of 7 minus y, followed by the addition of 1 is less than 17. Okay, so have that 17 to reappear. And I want to format this along the lines of any one of these 4 inequality scenarios where I had the absolute value term isolated on one side and the constants on the other. So have a little bit of work to do around here. Okay, so I can undo the presence of 1 by subtracting. Okay, so we have 2 times, okay, the absolute value of 7 minus y is less than 16. And we have dividing by 2. So I'm dividing by a positive number as opposed to a negative. Okay, so now I'm going to have the absolute value of 7 minus y is going to be less than 8. Okay, and so just taking what we have now, so I got absolute value term on one side. Now the k value is going to be 8. 8 is a non-negative, so I can proceed. Okay, so just taking what we have now, absolute value of 7 minus y is less than 8. This is going to run along the lines of the absolute value of x is less than k. Absolute value term less than k, where k is at 8. And in terms of the follow through, so once I take 7 minus y and situate, removing the absolute value bars, I'm going to have Okay, again, with x represented by 7 minus y, I'm going to have 7 minus y situated between negative and positive k, in this case, which is going to be negative and positive 8. And so we're now going to have negative 8 is less than 7 minus y, which in turn is going to be less than 8. Now I want to get the y term by itself. So if I take 7 away from both sides, or I should say all three portions of the compound inequality, okay, so we're going to have negative 8 minus 7 becomes negative 15. And we have negative 15 is less than negative y, which in turn is going to be less than 1. Okay, now I'm looking at solving for y, not negative y. So in terms of following through, if I multiply or divide everything in the compound inequality by negative 1, again, if you multiply or divide by a negative, the direction of each inequality section is going to change. So we have in the makeup here, okay, so negative 1 times negative 15 is 15. 15 is going to be greater than y, which in turn is going to be greater than negative 1. And if I rearrange the terms, instead of descending order, if I put in increasing order, so the smallest value I want on the left, largest on the right, so we have at the smallest end, okay, y is greater than negative 1. This is the same as negative 1 is less than y. And then we have at the upper end, to say 15 is greater than y, that is going to be the same as y is less than 15. And so we're going to have for the interval solution, okay, describing negative 1 is less than y is less than 15. So we have the limits concerned. We have negative 1 and 15. And without the equal signs for either half, okay, we're going to have negative 1 and 15 excluded. So we're going to have parentheses around these values. Okay, so this will be the interval solution outcome for what we have in problem 48. And for what we have for number 58, okay, so now we're looking at working with the variable d, and here we have that 15 is less than, we have the absolute value of negative 2d minus 3. And we have followed by the addition of 6. And again, I want to get the absolute value term by itself. And so getting the absolute value term by itself, I can move the 6 over by subtracting. So 15 minus 6 is 9. And we have that 9 is going to be less than the absolute value of negative 2d minus 3. And if I reformat this statement with the absolute value term on the left-hand side, okay, so I'm just going to switch this around. So to say that 9 is less than the absolute value of negative 2d minus 3 will be the same logically as the absolute value of negative 2d minus 3 is greater than 9. Okay. And so we have with this statement, out of your general inequality scenarios, okay, this one is going to run analogous to case number 4, okay, whereupon we have the absolute value of x represented by that of negative 2d minus 3, greater than k is represented by greater than 9. And this time, once I take out the absolute value bars, we're going to have these detached inequality statements. So we're going to have, at the lower end, we're going to have absolute value of x, again, absolute value of negative 2d minus 3 greater than k at 9 to become negative 2d minus 3 is less than negative 9, or x is greater than k, whereupon we have negative 2d minus 3 is greater than 9. And now solving for the variable d. Okay, so for negative 2d minus 3 is less than negative 9. So if I add 3 to both sides, so I will have negative 2d is less than negative 6. And upon dividing by negative 2, again, the direction is going to change. So negative 2d over negative 2 becomes d, and d is going to be greater than 3. Now we have with our other statement portion, again, starting from negative 2d minus 3 is greater than 9. So if I isolate the negative 2d term, upon adding 3 to both sides, so we're going to have negative 2d is greater than 12, and we have with division by negative 2, we're going to have in the results, okay, we have that d is going to be, and we have with division by negative 2, I had to catch myself. So again, if you multiply or divide by negative, the direction of the inequality changes to less than. Okay, so we have in effect that d is less than negative 6. So for the outcomes in d, it could be that d is greater than 3, or that d is less than negative 6. And just kind of providing a little bit of a visual layout. And say we have on the same number line. So we have at the ends here, have d is greater than 3. So we have a ray that's going to go out to the right. Now for what we have at the lower end, for d is less than negative 6, we have again a hole on negative 6, and a ray that will go continuously to the left. And so for what we will have in the case of the interval solutions, okay, so 1/2 you have those values of d, which will be less than negative 6. That's 1/2, and then we have the other half, we have in union with those values of d greater than 3. So yeah, this time For this half, we have parentheses containing 3 and infinity. Okay, so that would be the interval solution outcome for what we have here. Okay, and now let's see. Now, just some special cases you might run into in ALEKS. Again, still on page 103. Okay, say if you have in number 49. Okay, so we have like 2 times the absolute value of x plus 3 minus 4 is greater than or equal to 6. Alright, so we're looking at isolating the absolute value of x, which is represented by that of x plus 3. And so I'm going to get this term by itself. Okay, first of all, by adding 4 to both sides. Okay, so now we're going to have 2 times the absolute value of x plus 3 is greater than or equal to 10. And again, dividing by 2. So 2 times the absolute value of x plus 3 divided by 2 is greater than or equal to 10 over 2. So I'm dividing by a positive, so the direction of the inequality does not change. So we have that the absolute value of x plus 3 is greater than or equal to 5. So this is going to be taking a case, again, where we have the absolute value of x is greater than or equal to k. And so once you take out the absolute value bars, you're going to have, again, separate inequality statements that will be comparing the positive and negative values of k. Right. So you're going to have at the lower end, okay, we're going to have that x plus 3 is going to be less than or equal to negative k, which we will have at negative 5. And we have, or at the upper end, we're going to have the x plus 3 is going to be greater than or equal to 5. Okay, and so in looking at taking what we have and solving for x in these scenarios. So if I take 3 away for the first, okay, so I'm going to have the x is less than or equal to negative 8. And as for x plus 3 is greater than or equal to 5. If I take 3 away from both sides again, okay, we're going to have, along with the possibility that x is less than or equal to negative 8, it might be that, or that x is greater than or equal to 2. And so just looking at it visually. So for x is less than or equal to negative 8, okay, the equal sign signals that we have a close point on negative 8, and we have a ray that's going to go continuously to the left, approaching negative infinity. As for x is greater than or equal to 2, so we have what will be a close point on 2. And we have a ray that's going to go continuously out to the right. Then we have approaching infinity. So for the interval solution results, okay, so we have for the first half, we have between negative infinity, approaching and including -8. So -8 is going to be in the bracket. And then for the other portion, okay, we have going from and including 2. And 2, just like -8, is going to be enclosed in a bracket. And again, we have the upper limit approaching infinity. All right. So this will be the interval outcome that we have here. Now, what we have is sort of a special case for number 52. Okay, so you have that the absolute value of 2x plus 7 followed by the addition of 5 is less than 1. Right. So if I get the absolute value term by itself, okay, so upon deducting 5 on both sides, so we're going to have the absolute value of 2x plus 7 is less than -4. Okay, and again, absolute value of x you have represented by x, and we have in the format of x, absolute value of x is less than k, and k should be a non-negative value. And if you notice, we have the negative in front of the 4, and k cannot be any negative value. So that means in this case there will be no solution for this absolute value inequality statement. Now I think in Alex, like indicating no solution, this would be like an O with a slash, diagonal slash going through. And let's say if you have a fraction for the absolute value term, and say we have as a comparison inequality and the absolute value, okay, if we have the absolute value of m minus 4 over 2 is less than 14. Okay, so we have the absolute value of x is less than k. K is 14, which is non-negative. And with this setup, I can arrange a compound inequality, okay, where we can say that we have that -14 is less than x, which in this case is represented by m minus 4 all over 2, which in turn is going to be less than 14. And just getting out of the fractional notation, I can just multiply everything out by 2. So we're going to have here, okay, so I have 2 times -14 is -28, which is going to be less than m minus 4. And we have in turn is less than positive 28. And getting the m term by itself, so I'm going to undo the subtraction of 4. So if I add 4 in the middle, I'm going to have to do the same thing on the opposite ends. So if I add 4 throughout, okay, so we have with -28 plus 4. So this will come out to -24 is less than m, which in turn will be less than 32. And we'll have for the interval solutions in this one, okay, so you have between -24 and 32. So for the lower and the upper limits. Now the lower limit is going to be exclusive of negative 24. And the upper limit, okay, we have exclusive of 32. So you're kind of looking at almost like negative 23.9999, okay, reaching out to like 31.9999, okay. And so this will be the notation for the interval solution that we have for M. All right, and tell you what, in looking at solving absolute value inequalities, okay, so for determining the interval solutions, and I'm going to keep the pretty much the same terms, just a couple to work with here. Let's see what we get for the intervals, whereupon we have the absolute value of negative 2x is greater than or equal to 8. Also in the second, okay, whereupon we had the absolute value of negative 2x is going to be less than 8. So you got the same terms, but different types of inequalities. First one greater than or equal to, the next one less than. So let's see what we get for the intervals in these. Okay, so just looking at what we have in the inequalities. Okay, so for the first one we have the absolute value of negative 2x is greater than or equal to 8. And so you have the absolute value of x represented by that of negative 2x, and k is represented by 8. So k is non-negative at 8. And the nature of this inequality is going to be like the last case. And for what we have for the absolute value of negative 2x is less than 8. Okay, this is going to be a representation of the absolute value of x is less than k. Okay, so So removing the absolute value bars, okay, in the first equation. So rewriting what I have in terms of x is less than or equal to or greater than or equal to negative or positive k respectively. Okay, so we're going to have at the one end. So just taking negative 2x out of the bars. So we have the negative 2x is less than or equal to negative 8. Or it could be that negative 2x is greater than or equal to positive 8. And working with what we have in this situation. So for negative 2x is less than or equal to negative 8. If I divide both sides by negative 2 again, so I'm dividing by a negative, and so the direction of the inequality is going to change over from less than or equal to greater than or equal to, and so I'm going to have the x is greater than or equal to 4. And for what we have in the case of negative 2x is greater than or equal to 8. Okay, so if I divide both sides by negative 2, again, we're going to have the inequality direction changed, okay, from greater than or equal to less than or equal to, and here I have 8 over negative 2. So for the possible outcomes for x, it could be greater than or equal to 4, or x could be less than or equal to negative 4. So we have, for these extremes, okay, so we have for x is greater than or equal to 4, so you have a closed point. an array that's going to go out to the right. You have approaching infinity. Then for x is less than or equal to -4, so I have a close point and array that's going to go to the left and going in the direction of minus infinity. And so we have, in the case of the interval results, okay, so we have for the lower half, so I'm going from negative infinity, approaching and including -4. And for the upper end, okay, so I'm going from and including 4 and continuously increasing in the direction of positive infinity. Okay, so there'd be two sections in the solution when expressed in the interval notation. Okay. Now we have with the same terms but a different inequality, so we're transitioning from greater than or equal to less than. So in this setting, okay, so we have, upon taking out the absolute value bars, I'm going to have -2x to fall between negative and positive 8. So here I'm going to have -8 is less than -2x, which in turn is going to be less than 8. And once I divide by -2, I'm going to have the direction of the inequality sections to change. So if I had less than and less than, I can have it to change over to greater than and greater than. So we have in this rewrite, so we have -8 over -2 is 4, and 4 is going to be greater than x, and we have with 8 over -2, okay, so that is going to be in turn greater than -4. And again, just rearranging what we have here. So again, like with 4 is greater than x, that's going to be the same as x is less than 4. X is greater than -4 will be the same as -4 is less than x. So just rewriting in the order from smaller to larger and still maintaining the same logical consistency. So I'm going to have between negative and positive 4, and just sort of a quick sketch. Again, you have between -4 and positive 4. And on the number line, you would just have a line segment that would connect the circles. And so for the interval solution, you have going from negative to positive 4. And since neither of the limits values is included, okay, we're going to have parentheses around negative and positive 4. So conceptually, you're looking at going from like -3.999 all the way up to positive 3.999 and so on, but never quite getting to the limit values of negative or positive 4. Once again, for reminders, okay, the Alex homework section R6 is due tonight, and section R8 is due Wednesday, and just for kind of like test 1 review, okay, I have this list of exercises on page 113 from what I have listed from number 32, as well as going out to 104 through 106, and what I have listed in between. Now for key announcements, okay, we're about to wrap up pretty much the items of concern in Chapter R, and the first Math 171 test will be available through Alex and listed as Test 1 on Friday, February the 5th at 12 p.m. And there will be a 90-minute time limit, and the test must be completed in one sitting. In other words, you cannot save your work and resume at a later time as you would with just like the Alex homework. And the deadline for submitting will be next week on Monday, February the 8th at 11:59 p.m.